Okay, ladies and gents, this is the most recent C2 exam. This is the 2015 one, May, or sometimes it's called the June one. So the first question is the binomial expansion question. Now this one is a nice start to any exam because they can only do a certain amount with binomial questions, and the way we go about it is the same each time. So the first thing we do here is we write down that whatever this power is here, you write down as 10C0. Now remember, it starts off at zeros. Mistakes people have made in the past are making 10C1 as the first step. It's got to be 10C0. And we want the first three terms. So it's going to be 10C0, 10C1, and 10C2. Once we've done the 10Cs, or whatever the power is, C, from 0 up to 2, we then have a look at the first thing that's in the brackets, which is the 2. So we're going to multiply it by 2 to the power of 10. Then next thing we're going to do 2, and then we drop the power by 1 to the power of 9, times by 2 to the power of 8. The next thing we do is we take the second part of the brackets, including the sign of it. Now we skip the first one, but then the second term, this one here, we multiply it by minus x to the power of 4, and I often put this one in brackets. And the reason I put it in brackets is because when we do it again, minus x over 4, we're going to raise that to the power of 2. And unless we put it in brackets, we'd keep the minus sign, but we need to get rid of the minus sign. So just to recap, we start off with the 10 choose 0, 10 choose 1, 10 choose 2. Next step is we have a look at the first thing in the brackets. We start off on the right hand side and we do 2 to the power of 10, 2 to the power of 9, 2 to the power of 8. Then we have a look. The third and final step is to take the second part, including what's in what the sign is. We skip the first one, so there's nothing there. In the second one, we have it to the power of 1. The second one, we put it in brackets and do it to the power of 2. Once we've done all that, we simplify. So, again, if I go quiet, it's because I've got I'm doing stuff on my calculator. So 10 choose 0. 10 choose 0 times 2 to the power of 10. 10 choose 0 is 1. 2 to the power of 10 is 1024. So we get 1024 plus 10 choose 1 is going to be 10. So that's going to be 10 times by 2 to the power of 9. So that's 10 times by 2 to the power of 9, which is 5,120 times by minus x over 4. So x over 4, and we're going to make that a minus. Again, we can simplify and cancel that in a second. The next thing we've got to do is 10 choose 2 times 2 to the power of 8. So 10 choose 2 times 2 to the power of 8, which is 11,520. And then we've got times. So if we do this thing in the brackets squared, it's going to be minus x times minus x, going to be a plus x squared. Then you're going to have 4 times 4 on the bottom, so that's going to be positive x squared over 16. And then we simplify it. So the first one's going to be 1,024 minus 5,120 over 4 simplifies to 1,280x. If we simplify 11,520 over 16, that becomes 720 x squared, which if we then have a look at the mark scheme, we'll hopefully get that again. So 1,024, 1,280, and then 720. Hooray! So we're well on the way with our first 4 marks. And this is one of those questions where, at least if you're sort of confident getting the first few marks, then the rest tend to fall into line. So question 2 is, so the first thing we pick up on is a circle. It's got the center point and it passes through this point here. Find an equation for the circle. So the first thing I'd always do is write down the equation of the circle, which is x minus a squared plus y minus b squared equals r squared. Now, AB are the coordinates of the centre. So the first thing I do to make sure I've got some marks is substitute into my equation the coordinates of the centre. So it's going to be x minus 2 squared plus y minus minus 1 is going to be y plus 1 squared equals r squared. So over here, if I know that 2 across minus 1, that's going to be the centre of the circle. And it goes through point 4 minus 5. So 4 across, well, sorry, it's going to be down there. So it's going to look something like that. So we've now got to work out what the radius is. So the radius is going to be this length here. So I know that it goes through 2 minus 1, and it goes through 4 minus 5. So what I'm going to do is I'm going to do Pythagoras to work out what the radius is. So the change in horizontal distance, this one here is 2 across, this one's 4 across, so that's going to be a distance of 2. This one is 1 down, this one's going to be 5 down, so that's a distance of 4. So using Pythagoras, a squared plus b squared equals c squared. That's going to be 4 squared plus 2 squared, which equals c squared. So c, which is our radius, is going to be the square root of 16 plus 4, so it's going to be square root of 20. So the radius is the square root of 20. So if we go back up to this here, the radius squared is going to be square root of 20 squared, which is simply just going to be 20. So let's then replace that with 20, and I've got my first set marks for this question. Next thing, and again, if we've done a diagram, which is, it doesn't need to be that accurate, but it gives us an idea of what's happening, we can then sort of try and visualize what's happening in part B. So we're going to find an equation of the tangent to the circle C at point A. So this here is point A, and if it's a tangent, then what we do is we sketch. Oh, blimey, that's awful. Let's get rid of that. Sorry, my pen goes crazy sometimes when I put a ruler on there. Let's do another quick sketch. Apologies for this. So we've got 2 minus 1. We've got 4 minus 5 down here. And we've got our circle which goes here. And we've got a tangent which looks like this here. And we've got to find the equation of a tangent. So we need to know if they've asked us to find the equation of a tangent or the equation of a line, the first thing we do is we write down y minus y1 equals m x minus x1, just like we did all the time in C1. Now we need two pieces of information here. We need to know the coordinates, which are going to be 4 minus 5, and we also need to know what the gradient of this line is. Now there's nothing that tells us the gradient of the line at the moment, but we do know that a tangent and a radius are at right angles. So if we can work out the gradient of the radius here, we can then do the negative reciprocal to work out the other gradient. So just like before, we saw that across that was a distance of 2 that way and 4 that way. And we can see that from our basic diagram it's sloping downwards. So this gradient is going to be the change in height. So it's going to be 4 over 2. And the reason that I've put the minus there is because it's sloping downwards. So if we simplify that, that's going to be minus 2 as the gradient. So we have now got, so this gradient is minus 2, which means the perpendicular gradient here is going to be minus 1 over minus 2, which is going to be a half. So we've got everything that we need. We've got our coordinate and we've got our gradient. So let's substitute those in. Y minus minus 5 is going to be y plus 5 equals a half x minus 4. And then they say they want it in the format ax plus by plus c equals 0. So in that case, the next thing I'd do at this stage is I would get rid of this 2 on the bottom by bringing that over to the other side to make 2y plus 10. And then I'd multiply the brackets, leaving us with x minus 4. I then get everything onto one side. Now usually I make everything onto the positive x side, but in the mark scheme they may have put it onto the y side. But to be honest, as long as you've got it one or the other, it's absolutely fine. So x minus 2y, I then need to take away 10. So I get minus 14. So x minus 2y minus 14 equals 0. Hopefully, that should give us the answer. X minus 2y minus 14 equals 0. Yep, we're happy with that. And of course, part A was that bit there. Okay, so question 3. Question 3 is a real common question, and it's a nice one in a way because it's relatively straightforward. But the key to this one is that people do tend to lose marks by being sloppy and making algebraic errors. So just be really careful and double check this question when you go through it. So it says, given that when f of x is divided by x plus 1, the remainder is 45. I think what most people know what to do now is you substitute in the value of x that makes this bracket 0 and set that equal to 45. So what we're going to do is we're going to do f of minus 1. And because it says show that, it means that we've got to be really explicit. So it's going to be 6 lots of minus 1 cubed plus 3 lots of minus 1 squared plus a times minus 1 plus b, and I say that equals 45. So then once you've done that, you've got to then simplify everything. So minus 1 cubed is minus 1, so that times by 6 is going to be minus 6. Minus 1 squared, of course, is going to be positive, and it's important that you make sure that this is in brackets. If you don't put this in brackets, algebraic or numerically it won't be correct, and there you will probably dock you the mark. So 3 lots of minus 1 squared is going to be plus 3, and then minus 1 times a is going to be minus a plus b, and that equals 45. I'll then simplify it again, so minus 6 plus 3 is going to be minus 3. Minus 3, I'd say plus b minus a equals 45. So b minus a equals 48. Now, on these questions, a lot of the second question is exactly the same. So this one here is a factor. Now, factor means that the remainder will be 0. But often people make mistakes for what they substitute in as your value of x. So you've got to substitute in whatever makes this bracket 0. And if you're not sure on that, set that bracket equal to 0. So 2x plus 1 equals 0. So 2x equals minus 1. X equals minus a half. Excuse me. And then what you do is you substitute in minus a half into your equation up here and set it equal to 0. So doing that is going to be 6 lots of minus a half cubed plus 3 lots of minus a half squared plus minus a half times a plus b. And that equals 0. So minus a half cubed is going to be minus a half times minus a half times minus a half, which is minus an eighth. Times by 6, and you're going to get minus 6 eighths. Minus a half squared is going to be a quarter. So 3 lots, that's going to be plus 3 quarters. Minus half a, or a over 2, plus b equals 0. Now minus 6 eighths, we can cancel that down to minus 3 quarters. So you've got minus 3 quarters plus 3 quarters, which will cancel out. So if we then bring this to the other side, we've actually got b equals a over 2, or a equals 2b. So once we've got a equals 2b, we can substitute that into this one up here. So if we know that b minus a equals 48, and we know that a is 2b, then b take away 2b equals 48. So simplifying this gives you minus b equals 48, b equals minus 48. And then once you've got b equals minus 48, you substitute that in. So we've got minus 48, if we substitute it into this thing over here, minus 48 take away a equals 40, or in fact scratch that, why don't we substitute it into this thing here. So a equals 2 lots of b, so a equals 2 lots of minus 48 48, which equals minus 96. So we've got A is minus 96, and we've got B is minus 48. So it then says factorise f of x fully. So what we do is we can rewrite the top equation, except with our values of A and B. So that's going to be 6x cubed plus 3x squared minus 96x plus B, so that's going to be plus minus 48. Just put minus 48 there. So we then got to factorise it. And so by doing that, we're going to write it out, and we do long division. So whenever it says to factorise one of these things, we write it out in long division. So 6x cubed plus 3x squared minus 96x minus 48. And to that, we can we've got to divide in 2x plus 1. So what do we multiply 2x by to get 6x cubed? We multiply it by 3x squared. Then we multiply everything by 3x squared. So it's going to be 6x cubed plus 3x squared. So we do the top one divided, well, top one take away the bottom one, leaving you with minus 96x minus 48. You then need to see what you need to multiply minus what you need to multiply 2x by to get minus 96x. So by doing that, you need to multiply it by minus 48. And if you do that, that's going to be minus 96x minus 48, which should give you a remainder of 0. And if it doesn't give you a remainder of 0, it means that you've made a mistake. So what we now know is that 2x plus 1 multiplied by 3x squared minus 48 equals our function of x. But it's not completed yet because we need to factorise what we've got up here. So the first thing I'd do is I'll take out the 3. The 3 goes into that, and that will give you x squared minus 16. And that equals our function of x. The next thing we do is we've got to be able to spot in C2 that this is the difference of two squares. So if we do that, we get as a final answer 3 bracket 2x plus 1, x plus 4, x minus 4. That is our function of x, and that is fully factorised. Now if it says solve, what we need to do is we need to set it equal to 0 and find out what our values of x are, but it doesn't in this question. So if we just check our answer, we've got A and B, as we said, is minus 48 and minus 96. And then if we go down to the bottom, we get 3 on the outside, 2x plus 1, x plus 4, x minus 4. But note that if you don't take the 3 out as well, you will lose a mark. Okay, so question 4. It is a question where you've got to use the sector stuff. So the sector stuff that we need to know is that the arc length is r times theta, and the area equals half r squared theta. Now the first thing we've got to do is show that COD, so we've got to show that this angle here is 0.906, and there's two ways to do this. So we've got this dotted line here, which if we know that it's 16 all the way across, that's going to be 8 centimeters because this one is 8 centimeters and that's a sector. So this one's also going to be 8 centimeters. So we've got a triangle which is 8 centimeters there, 8 centimeters there, and 7 centimeters there. So if we've got to work out what this angle is here. So doing that, we can use the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a. So if we do that, a is going to be the one that's opposite the angle, so that's going to be 49 equals 64 plus 64 minus, in brackets, 2 times 8 times A, because B and C are the ones either side of the angle, cos A. So then if we simplify, that's going to be 49 equals 128 minus 128 cos A. We're then going to bring this over to this side and this over to the other side. So that gives us 128 cos A equals 128 take away 49, which is 79. Cos A equals 79 over 128. So then A equals the inverse cos of that, making sure that your calculator is in radians. So we've got 79 divided by 128. And if we do the inverse cos of that, we get A equals 0.90563. So three significant figures, we get 0.906. Now that's one way of doing it. But the beauty about this is that there are more than one way to do any of these questions. So what we could do is, if we've got an isosceles triangle here, then what we've got half of this length here. If we cut this right down the middle, we've got that as 3.5 centimeters. We've got this as 8 centimeters, and then we've got to figure out what this angle is here. So we've just got a basic right angle triangle. So if this is the angle here, if we call that alpha, we've got the opposite and we've got the hypotenuse. So opposite and hypotenuse, using SOHCAHTOA, we've got SOH. So we've got sine of alpha equals the opposite of the hypotenuse, which is 3.5 over 8. So alpha equals the inverse sine of 3.5 divided by 8, which equals 0.4528, and that's going to equal this angle here. So we need to double it to get all the way across. So times by 2 gives us 0.905633, just like before, 0.906. So you can use either one of those methods. Okay, so the next thing that we've got to do is we've got to work out the perimeter of the whole shape. So, if we have a look at the whole shape, we know that this is 7, we know that this is 16, so all we need to do is we need to know what this is here, which will be the same as this thing. So like I said at the beginning, we should know that the arc length equals r times by theta. Now we know that this here is 0.906 radians, and because it's a straight line, we should know that's 180 degrees, or we should know that 180 degrees equals pi radians. So if we do 180 degrees, which is pi radians, and we take away the 0.906, we're going to be left with both of these, which should be the same. So if we do pi, take away 0.906, so pi take away 0.906, and then we divide it by 2, we have left both of these angles here. So both those equals 1.12. So in fact, if we do it three decimal places, 1.118. So let's get rid of all the other information on the diagram that we don't need. I know that this one here is 1.118, this one here is 1.118. So I need to know what this length is here. So with my entire answer in the calculator, I'm going to times that by the radius, which we know is 8 centimeters, and that will give us this length here. Once we've got that length, we double it, because there's two of them, then add 7, then add 16. So you've got the 1.118 and all the other decimal places in the calculator, times by 8. So 1.118 times by 8, and that equals 8.942. So 8.942 is going to be these ones here. And then you add them all together. So 8.942 times by 2 plus 7 plus 16. And that gives you 40 to three significant figures, 40.9. And then you've got to work out the area. So just like before at the beginning, we are going to, and that was 1.118. So what we're going to do is we're going to work out the area of this triangle, which we know is half AB sin C. And as we said at the beginning, the area of a sector is half r squared theta. So the area of this one and the area of this one is going to be half times 8 squared times 1.118. Then because there's two of them, we've got to double that. Then we're going to add half times, we know that this angle here is 0.906, so half times r squared, which the radius is 8, so half times 8 squared, sorry, half times 8, sorry, my mistake, half AB times C, so it's still exactly the same, half times 8 times 8 times sin of 0.906, and you put that all into your calculator. So 0.5 times 8 squared times 1.118, and we get for each one of these sectors we get 33.118, which means double. So 33.118 plus 33.118, then you need to add on this thing here, so half times 8 times 8 times sine of 0.906, 25.2 or 25.185, and then we add them all together and we get a final answer, hopefully, of 91.4 centimetre squared. Let's just double check that answer. Oh no, we don't. We've got 96.7. So let's go back and have a look and see where the mistake was made there, because we should be getting an answer of 96.9. Okay, so I realised where I went wrong. It wasn't 33.118. If you do 0.5 times 8 times 8 times 1.118 in your calculator, you actually get, so that's wrong, it should be 35.776. So what we should have done is had 35.776 times by 2 plus 25.185 plus 25.185, we get 96.7. Which, when we check out in the book, 96.7 is the first answer, so hooray, we've actually got that one right now. I do apologise. Right. Question 5, here it is. All the terms of a geometric series are positive. The sum of the first two terms is 34, and sum to infinity is 162. So, we need to know the sum of geometric terms, and we also need to know the sum to infinity. The sum of terms is Sn equals either a r to the n minus 1 r minus 1, or a 1 minus r to the power of 1 r over n 1 minus r. And the sum to infinity is, if I write it down here, sum to infinity is a over 1 minus r. So if it's given us two sets of information, the sum of the first two and the sum to infinity, then we're going to be using this one here. So you're told that sum to infinity is 162. So I'm going to write down that a over 1 minus r equals 162. Now I've got to decide whether or not I use this one or this one. And I'm going to use this one because if you break this one down, we've actually got a over 1 minus r, which is going to help us solve them simultaneously. So we know that the sum of the first two terms is 34. So if I do a bracket 1 minus I, instead of the power of n, I know it's the first two terms, so n is 2 over 1 minus r, and that equals 34. Let's try and write in the correct number. Now we've got to solve this simultaneously. We can actually break this second one down as a over 1 minus r multiplied by 1 minus r squared equals 34. Now we know from the sum to infinity thing that we've got a over 1 minus r is the same as 162. So it means that we can get rid of this a over 1 minus r and replace it with 162. So 162 times by 1 minus r squared equals 34. So we can then divide by 162. And by doing that we get 1 minus r squared equals 34 over 162. And then if we bring this to the right hand side and this over to the left hand side, we've got 1 minus 34 over 162 equals r squared. So r squared equals 128 over 162, which we can actually simplify to 64 over 81. So r squared equals this. So r is going to be the square root of that, which you don't actually need a calculator for. Square root of 64 is going to be 8. Square root of 81 is going to be 9. So in theory, it could be plus or minus 8 ninths. But if we go back to the original question, it says all the terms are positive. So if we've got a negative common ratio, it means that the term's going to alternate from positive to negative to positive to negative. So therefore, it can't be minus 8 over 9. The actual value of r is 8 ninths. Okay, so we've got r equaling 8 over 9. So now what we've got to do is we've got to work out what the first term is. So we can then use anything that we've been using so far. So let's get rid of everything else here and just have the sum to infinity. So we know that r equals 8 ninths, and we know that a over 1 minus r equals 162. So let's have a over 1 minus 8 ninths equals 162. So a divided by 1 ninth equals 162. So a divided by 1 over 9, if you divide by a fraction, that's going to be a times 9 over 1. So that means that 9a equals 162. So a equals 162 divided by 9, which equals 18. So a equals 18. Okay, now a different geometric series has first term 42 and a common ratio of 6/7. Find the smallest value of n for which the sum of the first n terms of the series exceeds 290. Now whenever you have anything like this, we set it equal to 290. And we know that our answer isn't going to be nice, but then we need to round up to the next term. So we know that a equals 42. We know that r equals 6 over 7. And we need to have the sum of it equaling 290. So if we use a bracket 1 minus r to the power of n over 1 minus r, I want that to equal 290. So if we then substitute those in, so 42, 1 minus 6 over 7 to the power of n over 1 minus 6/7 equals 290. And that gets us our first mark. So then we've got 42, 1 minus 6/7 power of n over 1/7 equals 290. Now to get rid of the divided by 7th, of course we could times both sides by 1/7. So if we do that, we get 42, 1 minus 6 over 7 power of n equals 290 over 7. Then need to divide by the 42. So that's going to be 1 minus 6 over 7 power of n equals 290 over 7 divided by 42. We're going to bring this to the right hand side and this to the left hand side. And if we do that, we get 1 minus, and if we tidy up the the right hand side, we get 1 minus 290 over 294 equals 6 over 7 power of n. So 1 take away 290, 294 leaves us with 4 over 294 equals 6 over 7 to the power of n. Now this is going to be tricky, so what we need to do is we need to take logs of both sides. So log of 4 over 294, or if you wanted to cancel it down to 1 over whatever it turns out to be, that's fine, equals log 6 sevenths to the power of n. Now with any log laws, we should know that we can then bring the n down to the front. So we get log of 4 over 294 equals n log of 6 sevenths. And then we divide both sides by this here. So we end up getting n equals log of 4 over 294 divided by log of 6 sevenths. And we find out what that is. So we type that into our calculator and we get n equals, and you just bear with me, I'm doing that on my calculator at the moment. So log of the top divided by log of the bottom, and we get n equaling 27.877 blah blah blah. So it means that the 27.8th term will give us 290 exactly. But we can't get the 27.8th term. So we always round it up. Even if it was 27.1, the 27.1th term would give us 290 exactly. But that doesn't make sense. We've always got to round up. So if we round up, we get 28. So n should be the 28th term, which I'm hoping they give us. So yeah, n equals 28. And if we just double check our previous answers, a equals 18, r equals 8 ninths. So yeah, job's good. Okay, next question, question 6. I'm hoping that this video isn't coming out too fragmented, but I've been in the middle of teaching class, I've had to pause it every now and again. So if it does seem like it's jumping around a little bit, that'll be the reason why. And my apologies for that. And just because I know he'll be whinging and crying if I don't do it, shout out to Ashley today. I hope that you hear this, and it means that you'll have done your revision, so good boy. You wouldn't believe how long this video is taking me. I am now about 6 hours into trying to make this video, and I'm only 38 minutes and 46 seconds in. Craziness. Anyway, question 6 now. If we multiply this out, we're going to get, or we're going to have to integrate 10x. Remember, this is x to the power of 1, so if you multiply these two together, that you need to add the powers. So 10x to the 1 1/2, which is 3 over 2, minus, then if you multiply this, it's going to be minus 20x, and we're going to integrate that with respect to x. So integrating that, 10x to the power of 5 over 2 over 5 over 2, minus 20x squared over 2, and remembering, of course, the plus c. And again, get people to punch you in the arm if you forget that. We've then got to simplify this. So 5 over 2 is 2 1/2, so 10 divided by 2 1/2 is 4. Alternatively, if you bring the 5 over 2 underneath, the 5 goes underneath, and this over 2 goes back up to the top. So that's 20 over 5. Either way, it's going to be 4. So it's going to be 4x to the 5 over 2. 20 over 2 is 10, so minus 10x squared plus c. Job done. Okay, so next we've got to figure out the area of the total regions. Now, because this region here is underneath the x-axis, it's going to give you a negative number. And this one is going to give you a positive number. So therefore, you can't integrate between 0 and 9 because some of it will cancel out. So what you need to do is you need to integrate it and do it between 0 and 4, integrate between 4 and 9, and then see what you get. So once we've integrated this, we get what we get above, and then, so 4x to the power of 5 over 2 minus 10x squared. We're going to do that between 9 and 4, and we're going to work out what this region is here. So we're going to call this one A. So what we do is we substitute 9 in there. So if we're going to do 9 to the power of 5 over 2, that's going to be the square root of 9, then raise that to the power of 9. So it's going to be 3 raised to the power of 5. So the square root of 9 is 3. 3 to the power of 5 is 3. 9, 20, so it's 243. And then 4 lots of that, it's going to be 927, sorry, 972 minus, if we substitute 9 into this, 9 squared is 81, 10 lots that's going to be 810, so take away 810. And then what we do is we substitute 4 into that. So the square root of 4 is 2, then you raise that to the power of 5, so 2, 4, 8, 16, 32. 32 times 4 is 128, so it's going to be 128. Substitute 4 into this one, and it's going to be 4 squared is 16 times 10 is 160. So then if we simplify both of these, that's going to be 162 minus 32, which equals 194. So we've got A there equaling 194. And then what we do is we're going to work out what we call the second one B is. And so we've got to do exactly the same thing, except we're going to integrate this time between 4 and 0. Now if we substitute 4 in there, we already know that we get minus 32. So let's change this around, and then this time just substitute in 4 and 0. So substituting 4 in, we get minus 32. Take away, if we substitute 0 in, we get 0. So minus 32 take away 0 is going to be minus 32. So B is going to be minus 32, but we're going to take the positive value of that, so it's going to be 32. You then need to add those together, so you get 226 units squared, and I'm hoping that is correct. So 226, alright, we're back in the game. Okay, so question 6 done, moving on to question 7. Now, logarithms. Now, I've done my log video, so hopefully if you've seen that, and if you pause this question before we start it, this question should be relatively straightforward for you guys. But if not, just watch and see how we do this one. So we've got to write this answer out to 3 decimal places. So if we've got 8 to the power of 2x plus 1 equals 24, then what we do is we take logs of both sides. So log 8 to the 2x plus 1 equals log of 24. What we're then going to do is bring this down. I mean, we could write it as log to the base 10 or log to the base anything really. But I'm just going to use the log button on the calculator, which is to the base 10. So I'm going to bring this down to the front over here using the log laws. So it's going to be 2x plus 1. I'm going to still keep it in brackets equals log to the base 10. Well, in fact, I'm going to stop writing to the base 10. I'm just going to write it as log. We just assume it's to the base 10. Log 8 equals log 24. The next thing we do is we divide by log 8. Well, we've got a choice of two things. Either we can multiply the brackets and to get 2x log 8 plus log 8 and take away the logs from both sides and then divide by 2 log 8, or we can just, to make it easier, because we don't need to find exact values, we can just divide both sides by this to get 2x plus 1 equals log 24 divided by log 8, and then what we do is we take away 1 divided by 2, leaving us x equals log 24 over log 8, take away 1 and divide everything by 2. The reason that we take away 1 is because we've got a plus 1 here, so we take away that 1 and we divide by this 2, leaving us just the x. And if we do all that on our calculators, so log 24 divided by log 8, take away 1, divided by 2, and press equals after each stage of this, and we get x equaling 0.264, which I'm hoping will work. In fact, let's check that one now. 0.264, get in. Okay, next one. We've got to find the values of this. Now, this is one of those questions we've got to manipulate. So one thing that you should recognise, if you've got a log take away a log, that means that we can divide them. So let's do that to start off with. Log to the base 2 of 11y minus 3 over 3 minus 2 log to the base 2y. Now we've got another minus here, which means that we can divide as well, but we can't at the moment. Sorry, and all that equals 1. The reason that we can't do this log divided by this one, or log of this thing divided by y, is because we've got 2 here. So we've got to deal with 2 first. We can only divide if it's log take away a log. If it's not log take away log, then we can't bring the y underneath. We've got log take away 2 log, so we've got to deal with this 2 first of all. So the way we do that is log to the base 2 of 11y minus 3 over 3 minus, and if we deal with that 2, log to the base 2 of y squared. And now we've got log take away a log, so now we can deal with it by bringing it under. So that's going to be log to the base 2 of 11y minus 3 over 3y squared equals 1. Excuse me. So now we've got to try and remember what logs do. So the whole sort of first lesson on logs is we know that this thing, the base, the power of this answer equals this thing here. So rewriting it, what we get is 2 to the power of 1 equals 11y minus 3 all over 3y squared. Now 2 to the power of 1 is just 2. So now if we're going to solve this, and it starts to look like a quadratic, we're going to bring this up to here. So we need to multiply, so that's going to be 6y squared equals 11y minus 3. We're then going to bring everything onto the left-hand side to make it quadratic, so 6y squared minus 11y plus 3 equals 0. And then we've got to factorise that. So whenever we factorise that, I'd always go for the middle values rather than 6 and 1, so I'm going to go with 3y and 2y. Of course, it's not always the case, but in this case, I think it will be. So factorise that, and we get this here. So our two solutions are y equals 1/3 and y equals 3 over 2. Now it says find the values, and we've got 2 values. We've got y equals 1/3 and y equals 3 over 2. But it tells us that y's got to be greater than 3 over 11. So let's just double check that. 3 divided by 11 is, so this thing here equals 0.2727 dot dot dot. So therefore our answer's got to be bigger than that. We know that 1/3 is 0.333, and we know, so 1/3 is 0.333, 3 over 2 is 1.5, so yeah, they're both bigger than this. So yeah, those are our solutions. So if we have a look at those two, we'd get, 1/3 and 3 over 2. Cracking. Okay, so question 8. It feels like we're getting to the end. I've got 6 pages left. So let's have a look at this one first of all. So we've got sine 3 theta minus root 3 cos 3 theta equals 0. And we've got to solve that. Now, these sorts of questions we solve, if we've only got a sine, then we can just solve it that way. If we've only got a cos, we can solve it this way. We've got a sine and a cos here. and we don't have a sine squared or a cos squared, so we can't make it a quadratic. So if we can't make it a quadratic, the other solutions tend to be making it into tan. So what we could do is we could bring this over to the other side. So we get sine 3 theta equals root 3 cos 3 theta. And then we're going to divide by cos 3 theta. So we've got sine 3 theta over cos 3 theta equals root 3. Now we should know that sine over cos is tan. So we've got tan 3 theta equals root 3. Now, it's easy to solve when it's just tan of something equals root 3. This is tan 3 of something. So whenever we do this, we replace whatever we've got here with just a. So tan of a equals root 3. And then instead of this, we change the boundaries. So the boundaries need to be changed to 3 times it. Because it's 3 theta, you do 3 lots of the boundaries. So 3 lots of 0 is 0. 3 lots of pi is 3 pi. So we need to solve tan a equals root 3 in between 0 and 3 pi. The next thing we do is we sketch out the tan graph. So that's going to be 90, which we know is pi over 2. Then it looks like that there. Go up to there. So that's going to be pi and 3 pi over 2. 2 pi. 5 pi over 2. And this point here, which is 3 pi. So we've got to solve tan a equals root 3. So root 3 is like 1.7 something or other. So if we have a look at this, we're going to have this solution, because tan of this value equals root 3. So we're going to have that solution, we're going to have this solution, and we're going to have this solution. And they all give us root 3. So what we're going to do is we're going to use our calculator, the inverse tan function, to figure out the first one. So if tan of a equals root 3, a equals the inverse tan of root 3. And we've got to, again, make sure our calculator is in radians. So inverse tan of root 3 equals 1.047, which, I can't remember what that is. And if I don't know what it is, then what you do is you switch your calculator back into degrees. And then if you do the inverse tan of root 3, what you get is 60 degrees. Now I know that 60 degrees is pi, which is 180 divided by 3. So pi is 180 degrees, so if I divide that by 3, I get 60 degrees. So that 1.04 is pi over 3. So I know that this solution here is pi over 3. This second solution here is the first solution, and then gone on by 180 degrees, or gone on by pi. So I've got my solutions as pi over 3, pi over 3 plus another pi. So a third pi plus a whole pi is going to be 4/3 of pi. And then you're going to add another pi, so another 3/3, which is going to be 7 pi over 3. Now that's our solutions to A. But we don't want our solutions to A. We said that A was also the same as 3 theta. So to figure out what theta is, we need to divide by 3. So we get pi over 9, 4 pi over 9, and 7 pi over 9. That's going to be our solutions, which if we check, pi over 9, 4 pi over 9, and 7 pi over 9. Lovely. Okay, next one. Given that 4 sine squared plus cos equals 4 minus k, find cos in terms of k. Okay, what we've got here is something which involves sine squareds and cos squareds. Also, sine squareds and coses, or cos squareds and sines. So we know this one we're going to need to use the quadratic thing. But we've got to make sure that they're all either sines or all coses. So we know that sine squared x plus cos squared x always equals 1. So what we're going to do is we're going to rearrange this to get sine squared. So sine squared x equals 1 minus cos squared x. Then we're going to substitute that in. So that's going to be 4 lots of 1 minus cos squared x plus cos x equals 4 minus k. Then what we're going to do is a 4 minus 4 cos squared x plus cos x equals 4 minus k. Excuse me. And now the next thing we do there is we rearrange it so it is a quadratic. So we're going to bring everything over to the right hand side. So we end up with 4 cos squared x minus cos x. And if we take 4 from both sides, take 4 from that side, take 4 from this side, we're left with minus k equals 0. And so now we've got to find cos x in terms of k. So we've got to somehow solve this. So as we can't factorise it because it's a letter, we're going to need to either use completing the square or probably easier, the quadratic formula. So I'm fully aware this isn't an easy question, but it's going to be one that we need to be able to deal with, or at least start to deal with, so we can start to pick up the marks. So here a equals 4, b equals minus 1, and c equals minus k. So it's going to be minus b, so that's going to be minus minus 1, which is 1, plus minus the square root of b squared, which is 1, minus, then in brackets, 4ac, so 4 times 4 times by minus k, all over 2a, so all over 8. So then if we simplify that, 1 plus or minus square root of 1 plus 16k over 8, and that's going to be what cos x equals. So cos x equals 1 plus square root of 1 plus 16k over 8, and 1 minus 1 plus square root of 16k all over 8. Okay, so now when k equals 3, find the values of x in this range. So what I'd do is I'd probably go back to this one here, and then replace k with 3. I mean, you can replace it in what we've just done in terms of the quadratic. Because I think this is a more familiar territory, we'll go to this one. So we're going to replace the k with 3, and then we'll factorise it. So 4 cos x and cos x, and then we're going to have plus 3 and minus 1. So that will give us the expansion here. So then we've got solutions. We've got cos x equals 1, and we've got cos x equals minus 3 over 4. So then if we do our graph between, we don't need to change the boundaries here because it's just cos x. So let's draw the cos x graph. So it goes through at 90, 180, 270, and 360, and it goes from 1 to minus 1. Now the solutions, bear in mind it doesn't equal 360 here. So we've got a solution here where it's 1, but we can't use this solution here. So we've got x equals 0. So we've only got one solution for this one here, and that's where x equals 0. We've now got to do the solutions for when cos x equals minus 3/4. So minus 3/4 is there. So that's going to be that one there, and that one there. So if we stick into our calculator again, we have been doing a lot of work with radians, so make sure you calculate it goes back into degrees here. So the inverse cos of minus 3/4 gives us 138.6. So we've got x equals 138.6 degrees. And okay, so what we've seen is that from here, so from the top of our graph, we've gone in 138.6 degrees. So therefore, to find this one here, that's going to be 138.6 in on the top of the graph again. So we do 360, take away 138.6, and we get 221.4. And now we've done all that, so at the very bottom of the page I'd make it really clear and have all three solutions together. So 0, 138.6 and 221.4 degrees. Let's just double check that. And 139, 221 and 0. So yeah, it's pretty much exactly what we've got, except we were a little bit more precise with us. Okay, so now it's question 9. Just double check. Yeah, this is the last question. Okay, so we've got question 9, I'm going to find it. And this is one of those questions where if you can get the first part correct, fantastic, that will give you the first 4 marks. If you can't get it, don't worry, and certainly don't let it faze you, because there are some very easy marks here if you're used to doing it. Okay, so let's make a start on it. We've got a solid, in fact I've got a feeling I've done this question a few times now. So we've got a solid glass cylinder, which is used in an expensive laser amplifier, has a volume of 75 pi. So let's sketch it out. I'll always do a little sketch just to see what we're looking at. And we're told a little bit further down the question that the radius is r, and we're not told anything about the height, so I'm going to assume that the height is h. The cost of polishing the surface area on the glass cylinder is £2 per centimetre squared for the curved surface area. That's going to be the bit around the outside, and £3 for the top and the bottom. Given that the radius of the cylinder is r, show that the cost of polishing in C pounds is given by that there. In questions like this, always look for the easy marks. So it tells you that, so as long as you can get this down, so that the radius is r and the height is h, and you're told the volume is 75 pi. So I know the volume of a cylinder is going to be the circle on top times by how far down it goes. So the volume equals pi r squared times h. And we're told that the volume is 75 pi. So I know that pi r squared h equals 75 pi. I can cancel out. So I've got r squared h equals 75. And in doing that, that gets you your first mark. So all you're doing is you've told what the volume is, write your own version of what the volume is, because you know what the volume of the cylinder is, set them equal to each other, and you got your first mark. The cost, so it's the cost of polishing the surface area. So let's work out what the surface area is. So we've got the two surface areas, they've got the one on the top and the one on the bottom. So the surface area is going to be 2 pi r squared. So pi r squared is the area of a circle. You're going to need to double that, because it's the one on the top and the one on the bottom. And then also you've got the bit around the outside, the curved bit. Now if you have that curved bit and you slice it, or if you cut it down there and then fold it out, you have a rectangle, and that rectangle is h, and then the length along the top here, imagine if we're cutting this circle down, it's going to be all the way that there, that's going to be the length. So the length of it across here is going to be the circumference. Now the circumference of a circle equals pi times by diameter. In this case the diameter is 2r. So it's going to be 2r times by pi. So therefore the area of this bit here is going to be 2 pi r h. Now what you were told, so just to clarify, this bit here is the top and the bottom, this bit here is going to be the curved surface area. And what we're told is the cost is the top and the bottom, and that's going to be £3 per centimetre squared. So we're going to times this bit here by 3. It's going to be 6 pi r squared, which looks remarkably like what we've got here. Then the second bit of it, this bit, is going to cost £2. So we need to do this bit here times by 2. So it's going to be 4 pi r h. But that doesn't look like this bit here. So what we now need to do, and the reason that it doesn't look like that bit there, is because this one's got an h in. So we need to somehow get rid of an h and replace it with something that's going to make it look like that. Now the reason they gave you the volume here, and the reason that we worked this one out, is that we can rearrange that equation to get h. Now we know that r squared h equals 75, so if we rearrange for h equals 75 over r squared. We're then going to substitute that into this chap over here. And so if we do that, we've got c equals 6 pi r squared h plus 4 pi r times by 75 over r squared. Now, the r is going to cancel out with one of these ones, so it's just r on the bottom. And 4 times 75 is going to be 300, leaving us with 6 pi r squared h plus 300 pi over r, which is exactly what they asked us to find. Now, fantastic if you can get that, but if you can't, it really doesn't matter a bit, because these are the marks that I want everyone to be really confident getting, because these are the ones that never ever change. So we're going to use calculus to find the minimum cost. Now, as soon as you see minimum cost, turning point, maximum, any of those words, what we need to do, we need to know automatically that you differentiate it, set it equal to 0. So if we've got c equaling 6 pi r squared plus 300 pi, I'm going to bring that r up to here, so make it r to the minus 1. And we are going to differentiate with respect to r, so we're going to find dc by dr. That's going to be 12 pi r minus 300 pi r to the minus 2, which we can write as over r squared. So we differentiated it for some marks. We now set it equal to 0, and setting it equal to 0 gets us a mark in itself. So we've got 0 equals 12 pi r minus 300 pi over r squared. We're going to bring this thing over to the other side to make it positive. So we've got 12 pi r equals 300 pi over r squared. We're going to bring the r squared up to get 12 pi r cubed equals 300 pi. We're going to divide both sides by pi to get rid of that. Bring the 12 over by dividing it, so we've got r cubed equals 300 divided by 12, and 300 divided by 12 equals 25. So r equals the cube root of 25. Now, I think this is naughty, because the first thing you think of when you think of 25 has the square number. And here it's going to be the cube root of 25, which isn't nice. But as you learned from your C1 exam, chances are the questions aren't going to give you nice numbers. I mean, we'll just double check now. So that's question 8. Oh, question 9, we got the cube root of r. Let's see, does it tell us here somewhere? It doesn't tell us what r cubed equals. I won't worry too much, as long as our answer in a second is 483 or 484. So we've got a value of r, which is this here. Now it doesn't say find the value of r, it says find the minimum cost. Now we know that the minimum cost, or the cost, is found by substituting our value of r into that. So what we found is the value of r that gives the minimum. So what we now need to do is we need to take this, which is 2.92 blah blah blah, but we always need to substitute in cube root of 25, and we substitute it into this. So what I'll then do, just to prove what it is that we're doing, is C equals 6 pi times by the cube root of 25 squared plus 300 pi divided by the cube root of 25, and chuck into your calculator. So if you just bear with me 1 second whilst I do it. So 6 pi times that squared plus 300 pi divided by cube root of 25 equals, so C equals 483.48, and it says give it, so 48, so you round to the nearest pound, which equals 483 pounds. So yeah, so that was the answer that they were looking for. So you've got to be able to do that. So it says minimum, so we differentiate it. We set it equal to 0. We then solve to find out what R is, and we substitute that back in to our equation here to find out what the cost is. So once we've done that, justify that we've got our answer, which is a minimum. So I've got rid of it stupidly, but what we do is, if we know that C equals 6 pi r squared plus 300 pi r to the minus 1, dc by dr equals 12 pi r minus 300 pi r to the minus 2. Now this helps us find our minimum, but to find out whether it's a minimum or a maximum, we need to differentiate a second time. So when it says justify your answer, or justify that it's a minimum, or check that it's a minimum or a maximum, we need to differentiate a second time. So the first marks are going to be for doing just that. So d2c by dr squared, and that will equal 12 pi plus 600 pi r to the minus 3, which we can write as r cubed. And then what we do is we substitute in our value of r, which we of course know is a cube root of 25, into this thing here. And if we do that, we get d2c over dr squared equaling, bear with me, I'm just doing it on the calculator as we speak, 600 pi divided by the cube root of 25, and we get 682.3. Now we know now that d2c over dr squared gives a positive value, therefore it is a minimum. And that's it. Done with 16 minutes to spare. So as long as you understand everything that we've done on this paper, you'll be absolutely golden for your exam. So what you need to do is you need to go back through everything that we've done here, and we need to understand why everything was done like that at each point. If you can understand it, then you understand the concepts behind it, and then you will be able to replicate it in your exam. If you could just redo this question again, that's not quite the same as understanding it. All we've got to do is understand the reason why, and if you can do that, fantastic. Okay, best of luck.